Okay, this session is about rearranging formulas that has log functions in. So I'm going to start off with a formula that adds up decibel values together. And imagine that you had a situation where you had n identical machines, each giving out equal amounts of sound intensity level. So for that particular case, the formula that we would have is this one. So we have identical levels and we have n such machines. So in this particular thing, the best thing to do is to give you some values and work out how many machines contribute to a certain level. So let's suppose that we're told that the level of each individual machine is 73 dB, and we're told that the level in this particular environment or this workshop has a maximum level of 80 dB. This obviously corresponds to the lower action value in the noise at work regulations. So the question then is, how many of these 73 dB machines can we have in the workshop before we reach this magical figure of 80 dB? So we shall put some numbers into this formula. So the total level, which is this one here, is 80. So we have 10 log 10 to the L over 10. As we know that L over 10, 73 divided by 10 is 7.3 times N, which is the number of these machines that's possible. So therefore what we're doing is that we're doing this equation almost like back to front. We're looking to see how many of these will contribute towards an 80 level. Just to remind you how we do this, we have to first of all isolate the term that's got the unknown in, which in this case is this one here. It's a log function. So what we do first of all is take the 10 across. Here it's 10 multiplied by log. Across the other side becomes 80 divided by 10. So this becomes 8.0 equals the log of 10 to the 7.3 times n. Okay. As discussed in class, to get rid of a log function, we have to anti-log. And if we anti-log this side, we also have to do the same on this side. So basically anti-logging raises things to the power 10. So this would be 10 to the 8.0. In this side here, anti-logging a log simply just basically removes the log away. So we end up with 10 to the 7.3 times n. So this means therefore that keeping n on its own over here, we can then take the 10 to the 7.3 to the other side, which becomes divisible. So this is the sum that we end up with, and if we do this calculation on the calculator, we get a value of 5. So again, this is quite an useful calculation to do in any sort of industrial environment where we're actually adding up individual sources, and if we've got a fixed level that we cannot exceed. That concludes that short tutorial.